We're going to look at these questions and these examples on constant acceleration formula. You may be aware of these as the SUVAT formulas, and they're called SUVAT formulas because they involve S, which is your displacement, U, which is your initial velocity, V, which is your final velocity, A, which is acceleration, and T, which is your time. So you may have heard these as SUVAT equations. 4 equations which we need, and I'll give you a bonus one. So V is equal to U plus AT, and S is equal to UT plus a half AT squared. V squared equals U squared plus 2AS. S is equal to a half U plus V times T. And a bonus one, which is very similar to this one, is S, your displacement, is equal to your final velocity times time minus a half times your acceleration times time squared. Okay, we're going to look at how we use these equations, and you can see what the letters all work there. If you pause the video, you can read through all of that. And a couple of key things at the bottom there. If the direction of motion changes, then the body must first stop before it does this. It must come to rest. So the distance travelled and the displacement should be considered separately. And deceleration, or another word for this is retardation, means slowing down. And it is negative acceleration. So if you're decelerating, that means your acceleration is negative. Okay, and then they've just mentioned that other formula that I've just given you as well. So your SUVAT questions, these are your constant acceleration formula questions. Okay, first example says a stone. Sorry, it doesn't say that at all. It says a cyclist traveling downhill accelerates uniformly, so that means constant acceleration, which means your SUVAT equations are valid. So uniformly at 1.5 meters per second squared. If his initial velocity at the top of the hill is 3 meters per second, find how far he travels in 8 seconds. Okay, lovely questions these. You set it up, you write down what you've got. You've got your A is 1.5. His initial velocity was 3. You want to find out how far he travels in 8 seconds and write down what you want. Okay, you look back at your 4 equations and you think which equation uses these 4 letters. And it is, and you write it down, S equals UT plus a half AT squared. Okay, and all you've got to do is fill it in. So Sn in this case is equal to 3 times my T, which is 8, plus a half times my A, which is 1.5, times my T, which is 8 squared, and you do that on your calculator. Don't be a hero, just do it on your calculator, and you'll get, hopefully that's right, 72 meters. Okay, part B. Part B says, find how far he travels before reaching a velocity of 7. So your A is the same, 1.5, your U was 3, and I want my velocity to get to 7, and I want how far he travels. So we want to find S again, but look, we've got 4 different things here. We don't have the same 4 letters that we had. So you look and you see which of my equations above uses these letters, and the equation would be, I'll write it up here, V squared equals U squared plus 2AS. So let's just fill it in. 7 squared is equal to 3 squared plus 2 times 1.5 times S. And then let's just sort that out. 7 squared is 49, 3 squared is 9, 2 times 1.5 would be 3S. Bring that 9 across. So that's going to be 40 is equal to 3S. And then your wee bit of working out, S will be 40 divided by 3, whatever that works out to be, 13 1/3 meters. And that's it done. So there's your first example done. Okay, right, next example says a stone slides in a straight line across a horizontal sheet of ice. It passes a point A with a velocity of 14 meters per second and a point B 2.5 seconds later. Assuming that the deceleration is uniform between A and B, find the deceleration, the velocity at B, and how long after passing A the stone comes to rest. Okay, right. I'm just going to do a diagram here to keep me right here. I've got A and B, and it passes A with a velocity of 14 meters per second. And then 2.5 seconds is the time between A and B. It passes A with a velocity of that, and at point B 2.5 seconds later. And you know also that A to B is 30 meters. So you've got to find the deceleration. So first thing, my U at A is equal to 14. My speed, my initial velocity is 14. My time is 2.5. My distance is 30, and I want to find the acceleration. That's what I'm looking to find. So I'm going to use S is equal to UT plus a half AT squared, because that's a formula which involves all four of these things. So just plug it in then, and you've got, that's going to be 14 times 2.5 plus a half times my A. Sorry, I'll just write my A just like beside it, and then 2.5 squared. Okay, when I did this out, what I'm going to get then, I'm going to have 14, let me just check this, sorry, I'm going to have my 14 times the 2.5, 14 times 2.5 gives me 35. Let me just work that out a wee bit. Nice, so it's going to be 35 then, and then 2.5 squared, and then times a half, that is 3.125. So that's 3.125A. So then bring the 35 across, you'll have minus 5 equals 3.125A. Your A is going to be minus 5 divided by 3.125. And my A worked out to be minus 1.6 meters per second squared. Okay, read the question. It asked me to find the deceleration. This was my acceleration, just say therefore. 3 wee dots means therefore. The deceleration is equal to 1.5 meters per second squared. Okay, that's the first bit done. Next bit says the velocity at B. So the velocity at B then. So we have got, we'll set this up again, will we? We will indeed. We'll go for we know the initial velocity was 14. My distance, or my time, sorry, we'll go for 2.5. We'll use acceleration, which we know because it allows us to use this very nice wee formula. So we're trying to find our velocity. So that's what we've got. So if you look back, you're thinking how we got this. Initially at A, I was going at a speed of 14 meters per second. The distance from A to B is 30. We didn't use that actually, but our time from A to B is 2.5. We've just worked out our acceleration is minus 1.6. We'll use this because this allows you to use a really easy formula. V is equal to U plus AT. So in this case, V is equal to 14 plus minus 1.6 times my time, which is 2.5. Again, don't be a hero, fire that into your calculator. And I got 10 meters per second. Okay. Part C, what it asked me to do in part C is find how long after passing A. So, right, we've started here and we want to find how long it takes me. So it's going to be out here somewhere that I go to a speed of 0. So that's really what we're looking for here. So you only got your initial velocity of 14 and you know your deceleration, but we know something else as well. That's how we think about it. Okay, so for this one, my initial velocity at A was 14. My acceleration, I should say, is minus 1.5. If you come to rest, your velocity is 0. So I'll just put that in. If you come to rest, so at rest, your velocity is 0. And we want to find how long. So we're looking for time. Oh, happy days, we got to use the easy equation again. Brilliant. So we're using V is equal to U plus AT. So V and, yes, we just fill that in. We know our V is 0. Our U is 14. Our A is minus 1.6. And T is what we're looking for. Let's just bring that 1.6 across, make it positive. Which means T is equal to 14 divided by 1.6. Which is, and hopefully I've got this written down here, hopefully this is correct, 8.75. Just check that please if it's not. Adjust it, 8.75 seconds. And that's it. Lovely. Okay, next example says we've got a train traveling at 60 kilometers per hour on a straight railway track. The driver of the train sees a red signal 500 meters ahead and immediately applies a brake and brakes. So that should be brakes. That is spelled incorrectly. That should be brakes with an AKE. Applies the brakes so that the train decelerates at 0.25 meters per second squared. Find how far the train is from the signal when he comes to a halt. Okay, so first of all, this is from A to B we're looking at then. So as if he's starting off then. So, oh sorry, it's nonsense. Ignore that. His velocity, I should say, I don't know what I was doing there. My velocity was 60 kilometers per hour. Let's get this into SI units. So that means basically in the meters per second. So if I go 60 kilometers per hour, I go 60,000 meters per hour. So what I've done here is I've multiplied by 1,000. And then I'll go into meters per minute. So if you imagine you've gone 60,000 kilometers per hour, you'll go 60 times less in just one single minute. So that's going to be 1,000. Yep, 1,000 meters per minute. And then to get that into meters per second, which we want, you're going to go 60 times less again, which is going to be 1,000 over 60. And let me just check that. 1,000 divided by 60 is, and that's going to be, yep, 16. So my U is equal to 16 and 2/3 meters per second. So that's a bit of work to do before we can even get started. Okay, so what we want to do then, so we've got our U. We want to find how far the train is when it comes to rest. So initially this train is going along at a speed of 16 and 2/3 meters per second. It comes to rest, so that's going to be V, and we're told it decelerates at 0.25 meters per second squared, so minus 0.25 is your acceleration. And you want to find the distance, and then what we can do is take that away from 500 to find how far it is away. So first of all, we're going to use V squared equals U squared plus 2AS. So 0 is equal to, and if you fire that in your calculator, the exact value of 16 and 2/3 squared on your calculator is 2500 over 9. And then your 2A then works out to be, that's going to be minus a half, and then S. So that means a half S is equal to 2500 over 9. Again, do this in your calculator, divide across just to make sure you get this right. It's going to be, work out as a mixed number as 555.59 meters. Okay. So he sees a red signal 500 meters ahead and immediately applies a brake so that the train decelerates at that speed. So how far he is from the signal when he comes to halt. So he's actually gone past, he's overshot the signal. So your answer then, it's going to be 555 and 5/9 minus 500. Okay, I thought he was going to come to rest before, but he doesn't. So that's going to be that many meters, and we'll just say after the signal. Okay, and that is it. Right, it says, what is the velocity of the train when he passes a signal? So what is the velocity of the train when he passes a signal? So for part B, let's just write in what we know. We know our U is equal to 16 and 2/3. That was his initial velocity. The distance to the signal was 500 meters. We know his acceleration is minus 0.25, and we want to find his velocity. So that's what we're looking for. Okay, so let's just go through that again there, please. You've got your initial velocity, we did a wee bit of working out to find out, was 16 and 2/3. His distance to the signal was 500 meters, and then the acceleration was minus 0.25. So you're going to use again V squared is equal to U squared plus 2 AS. So V squared in this case is 16 2/3 squared plus 2 times my A, which is minus 0.25, times my S, which is 500. Fire that all into your calculator. I got 250 over 9 as my V squared. My V then works out to be 5.27, and that's going to be meters per second, and that was the 2 decimal places, or 3 sig figs, whatever way we want to look at it. Okay, so that's out. Done.